To begin our discussion of standard forms of categorical propositions, we'll start with A and E propositions. So as I was saying in the previous video, there is a standard form that all categorical propositions should follow. Now, the actual content of those propositions will differ according to the different sorts of quantifiers going on and the other forms going on in the proposition. So, the first few forms of categorical propositions that you will encounter will be, the first one being the A proposition. Now, the A proposition here is just your very standard all S, S being the subject, are P, P being the predicate. Okay. The actual definition of an A proposition, what an A proposition is saying is the following. It's saying that all members of the S class are members of the P class. Okay. So your book gives you kind of a Venn diagram in order to demonstrate what's going on here. So we'll go ahead and I'll just allude to the Venn diagrams. They do analysis according to Venn diagrams, so we're not going to do that per se. We'll talk about this next week. I think there's an easier way of determining, the validity of categorical arguments, but we'll get to that in time. So, but to use a Venn diagram to demonstrate what we mean here when we say all SRP, we would do the following. We would say we put our two circles here. This would be our subject circle, this would be our predicate circle, and again, remember, with the terms in categorical propositions, we're talking about classes of things. So if you had our example, I think we had this earlier, of all cats are mammals. What this is saying is that if, in this case, the subject here is cats, and the predicate class here is mammals, this is saying that if you find something that is a cat, it's going to always also be a member of the class of mammals. So we demonstrate this with a Venn diagram by doing this. So what we are basically saying is that anything which is a member of the subject class will always be within the circle of mammals, or the class of mammals here. There will never be a case in which you will find a cat that is not also a mammal. That's what this Venn diagram is demonstrating here. Now, you may find things that are mammals which are not cats, and again, that's what this is showing here, is that there could be things out here in this part of the circle that are not cats, but are still mammals. And so this is what the A propositions demonstrate. Okay? So, when we talk about the actual breakdown of these propositions, aside from the Venn diagram here, we should note a few points here. So when we talk about these four different kinds of propositions, we always note what we call the quality and the quantity of these statements here. When it comes to A propositions, the quality we are referring to is what we call in categorical logic as affirmative. So it's affirming that S is a member of P. That's what that refers to there. So this is when we say an A proposition is affirmative. And we also refer to the quantity of a categorical proposition. The quantity is in reference to what the number of members of a class that are included. And in this case, we have the quantifier of all. So when we say that within, we're saying that the quantity of an A proposition is universal. Right. So, in other words, we sometimes refer to A propositions as universal affirmative propositions here. All right. That's the main thing to keep in mind with these propositions here. Right. So let's talk about another universal proposition, one that is universal but is not affirmative here. And in this case, it would be what we would call a negative universal here. Negative universal propositions are what we also call E propositions. So when we're talking about negative universal propositions or E propositions, the form of those propositions will be no SRP. In other words, no member of the S class is a member of the P class. Again, it's negative, it's negating something, it's pretty self-explanatory on this. So we could have an example like, for instance, no cats are reptiles. Okay. So again, let's use our Venn diagrams to demonstrate this fact real quick. So again, we set up our Venn diagram in the way that we did previously. So we put our S class over here and our predicate class over here. And let's take our example here. So once again, the S class is cats. And this time the predicate class are referred to reptiles. So what the E proposition is basically saying is that if you find a cat, it will never be a reptile. And likewise, if you find a reptile, it will never be a cat. So we symbolize this by shading out the middle portion here where in the Venn diagram where the two classes overlap. So you'll never find a case where there's going to be a cat that's in this middle part here where the Venn diagram, where the circles meet. They are always separated from each other. That's what the E propositions claim. And again, they are universal here because it's referring to all members of the subject class and all members of the predicate class here. Okay.